Okay guys, welcome back to my channel. Now, moving on from the last case for motion of connected particles, we're now into case 4. Now in this case 4, we have two masses again. Okay, we have a mass on an inclined plane and a mass hanging freely, and we'll be asked to find the acceleration of the entire motion. Now how do we do this? Already I have given you the forces acting on the masses on this system. Okay, on every inclined plane, every object on an inclined plane basically have what we call a sliding force, and that sliding force is a pattern or a particle of their weight acting down along the plane, and it is mg sine theta. So since we have mass 1, we have m1g sine theta, and then the mass hanging freely is m2. So we have these structures on the board. Now let's get down to business. Now quickly, we're going to separate the diagrams into two parts. We're going to work with mass 2 first and then mass 1. Now, to not waste our time, we've already done something that looks like mass 2 before in our previous cases, right? Yes. So therefore, we can just quickly say for mass 2, the tension is just equal to m2g minus m2a. Don't forget, for mass 2, the tension is equal to m2g minus m2a. Now, for mass 1, remember, since this object is moving this way, it means mass 1 is moving upward, and the force in that direction is the tension. So we can say the tension is greater than the sliding force for mass 1. So since we have T greater than this guy, we're going to say it means that T minus m1g sine theta is going to be equal to m1a. Therefore, we can make T the subject of formula. We're going to say T becomes equal to m1a plus m1g sine theta. Now, equation number 2. Okay, we have T in equation 1 and T in equation 2. We're going to equate them so we can find A. So, moving on, we're going to have m2g minus m2a equals m1a plus m1g sine theta. Now don't forget, we are looking for A. We're going to collect like terms with respect to A. So I want this m2a to go here and this m1g to come over here. We're going to have m2g, okay, minus m1g sine theta equals m1a plus m2a. Remember, g is common at the left hand side, so we can say m2 minus m1 sine theta all into bracket g becomes equal to m1 plus m2 all into what now? A. Remember, we are looking for A, so we divide both sides by m1 plus m2 and do the same on the left hand side, m1 plus m2. So this takes out this. We can say finally that the acceleration becomes, okay, m2 minus m1 sine theta all into g divided by m1 plus m2. So this is the formula for finding the acceleration for case 4, and these are the ways to find the tensions. Thank you very much. Watch out for my next video.